All right, so now we're going to walk through how to take the observations that we have from slide 5 and turn them into a claim and evidence for writing the first two parts of our CER. So the key question remains the same. How does the way energy is stored in the system change as the skater moves through the half pipe? What happens to the total energy in the system? All right, so typically, the claim will write itself if you have the evidence that you need to back it up. So the claim should probably be the last thing that, I mean, you can write it first, but that presupposes that you completely understand what's going on in your experiment, which is not always the case. So write the claim second. Let's figure out what evidence we need. Use screenshots, sketches, state diagrams, and words to demonstrate your observations that prove your claim. Since you're trying to show a comparison, you'll need to show at least two different states. Do not explain anything, just show it. All right? So let's go back to our simulation and capture some screenshots. That's going to be the best way for us to make it clear. Here we are back again at the half pipe. And if we see that we're at the very top of the ramp, and at this point, the energy pie chart is all blue. It's all potential energy. Its speed is 0. So the potential energy is equal to the total energy in the system at this point. All right. Let's take a screenshot of this screen, and then we will paste it into our Classkick as one of the state diagrams. So I've got that screenshot taken. I go up here, add an image. I'm going to add it from my computer because on my computer anyway, it is stored into the pictures folder where it's called screenshots. So I select that. Open it up. Because I'm working on two monitors, it takes a great big chunk that I'm not really interested in, but I get to select what portion of this picture I want. So I'm going to take all of that. And I could probably cut it down a little bit, but let's not get too disco. Okay? So I select that. I'm going to say finish that baby. And I will put it in place. Ooh, I think I'm going to size it down just a skosh. Let's see. Okay, so that might be a little on the small side, but we'll see. All right. Okay, so I'll do that, and then I will do the same for another state, another situation in our experiment. So let's go back to the simulation, and we will let it run. Let it go a little while. I've got it in slow motion so I can see things a little bit better. And let's just let it go once, and then I'll stop it just before it gets to the bottom. All right, so I'm going to step through, and it looks like everything, it's all green now. So now we're in a situation where the total energy is all as kinetic energy, 0 potential energy. Right? The speed is at its maximum. We can prove that by hitting the go button again, but it's as high as it ever went. So speed keeps going up and down and up and down. Right? So let's take a picture of this, and we will use this as our second state. So here I've done the same thing. I took a screenshot and cut and pasted it. And you can see that all of the energy is in kinetic energy. The amount of energy, the total amount of energy is the same in both of these. But in this one, it's all potential energy. This one, it's all kinetic energy. The speed here is high. The speed here is 0. The height here is 0. And the height here is high. So the potential energy, the gravitational potential energy, which is what we're talking about in this situation, is maximum when the height is the greatest, and it is minimum when the height is 0. Similarly, the kinetic energy is maximum when the speed is highest, and it is minimum when the speed is zero. Speed is zero up here, right? So you could just say those are the two different states. The question, though, is how does the way energy is stored in the system change as the skater moves through the half pipe? I'm going to let it go up here, and I'm going to take a screenshot of that as well. So in this case, I'm thinking that three states will explain the situation a little bit better. So I'm going to do that real quick. So again, I'm going to size this down. I probably could have cut it down a bit more, but I'm not trying to make this perfect right now. I'm trying to illustrate for you all how you might do this. All right. So let's name each of these states. Let's come up here and say, what would we call this? Let's say beginning, call this one the middle, or maybe I'll just call this one kinetic. All kinetic, let's say that. Let's rename this one all potential energy, all kinetic energy. And then I'm going to basically do this one again. I don't think I can copy and paste too well in this program, so I'm just going to just make another one and put it down here. So all potential energy. Yeah, might as well be consistent, right? So here we have most of the information. You can, if you want to make this clearer, you could actually say, in order to answer your questions, in the beginning, the potential energy, or all of the energy is in the form of potential energy when the skateboarder is at the highest point. And on this, I could just write that out here. So when the height is greatest, all of the energy is potential energy. Okay. Might want to make these a little bit smaller, just so I've got space enough. Put it on there, boom, right? And then I could say when the height is least or lowest, all of the energy is kinetic energy. Now, maybe I want to be a little bit more explicit and say, make these a bit bigger, when the height is the greatest and the speed is the lowest, all of the energy is potential energy. When the height is the lowest and speed is the highest, all of the energy is kinetic energy. And then basically I'd say the same thing, right? I make another box here, let's pull it out to there, so they all match, and I'll just paste that, right? Now what else was it asking us? We were being asked, what happens to the total energy in the system? Let's make sure we answer that. So what is the answer? The total energy of the system does not change. right, let's just put that in place. And the reason I'm walking through this in detail is so you have an example to follow for all of the other screens. All right. Now, what are we missing? We might be missing some intermediate step where you see that some of the energy is kinetic energy and some of it is potential energy. That's up to you. That's if you think that you can answer the question given this information, this evidence, then I think you're good. So I will leave you to it. Remember that in this evidence section, you're not explaining anything. You're just showing it. So right here, I'm not explaining anything. I'm not saying anything that is not in the image here, in this depiction, this state diagram. Not exactly a state diagram, but it's a way of capturing all the information that you got. I'm not making anything up. The amount of energy in the system hasn't changed. It just changed from potential to kinetic back to potential. But this is just observations. That's all you put in this section. So now it's time for us to see if we can write our claim. So how does the way energy is stored in the system change as the skater moves through the half pipe? And what happens to the total energy in the system? You could say the total energy in the system remains constant and the potential energy becomes kinetic energy as the skateboarder decreases in elevation, and the kinetic energy becomes potential energy as the skateboarder is climbing in elevation. That might not be as graceful as you might be able to make it, but that's the basic idea. I will leave you to craft your own sentences.